In this video, we'll be solving a question involved a block of mass, and the question says a block of mass M rests on a plane inclined at angle theta. You apply a horizontal force of F equal to mg to the block as shown. Good. So the A part, assume that the friction force between the block and the plane is large enough to keep the block still. What are the normal and friction forces? Call them N and F subscript F that the plane exerts on the block. Then the second part says let the coefficient of the static friction be mu. For what angle of the theta will the block remain still? So in this case, we'll be looking for three things. The first two will be the normal and the frictional forces. The second part will be the angle. So let's repeat the diagram. I have an inclined plane. So with the mass so this is the mass M, and we were told that a horizontal force is applied. Horizontal force is applied, and there is as well a frictional force. The frictional force, which we are told to represent as F, small f, capital F, subscript F. So we have this, and as well a normal. There will be force. The force on the mass of this will be acting downward, and this is same thing as, let me change the color. I have this, and this will be acting downward. Here is theta, there should be theta as well, and this will be mg cos theta. So we have this to be normal. The normal, apart from the force acting upward, which will be F cos theta, or F equal to, let me change the color as well. F equal to mg cos theta, which is pulling it up. Then this mass as well will be acting downward. It will be trying to slide down, which is as well F, which is as well as mg sin theta. And there will be another force perpendicular to the plane, and it will be pointing downward, which is mg sin theta. So with all this, let's see if we can try to analyze them. And for this, the normal will be equal to mg cos theta plus mg sin theta. And we know that the frictional force F is equal to mu S, which is the static friction, mu S K, mu S N. And since we already have, okay, let's term this equation 1. Since we already have N to be this, so we can rewrite the frictional force to be equal to F, subscript F is equal to mu S into mg. Okay, let me take the mg out. Mg into cos theta plus sine theta, and this is equation 2. So for this, I've noticed something. The frictional force should be against the force, not in the direction of the force, which is the frictional force will be pointing downward. It will be pointing downward, and we have the net force to be mg cos theta minus mg sin theta minus the frictional force is equal to 0. So, and we already have the frictional force to be this expression, and we can say that mg cos theta minus mg sin theta minus mu s mg cos theta plus sin theta is equal to 0. So we can rewrite this by having mg into cos theta minus sin theta is equal to mu s mg cos theta plus sin theta. So, and mg can cancel mg, and we'll be left with cos theta minus sin theta is equal to mu s cos theta plus sin theta. Okay, I can decide to open this bracket by having cos theta minus sin theta will be equal to mu s cos theta plus mu s sin theta. Okay, let's try to collect the like terms. I have sin theta over here, so I have cos theta. Okay, let's take cos theta over here. So we have cos theta minus mu s cos theta is equal to mu s sin theta plus sin theta. So if I decide to simplify further, making this theta the subject formula, I have that this is cos theta will be equal to 1 minus mu s this is equal to sin theta into mu s plus 1. And we decide to divide both sides by cos theta, and we will be having 1 minus mu s is equal to sin theta over cos theta mu s plus 1. So if we decide to simplify further, sin theta and cos theta is equal to tan theta, and from our trigonometric ratio we have a 1 minus mu s is equal to tan theta into mu s plus 1. So, and we can decide now to make the theta the surface of formula. Tan theta, which is tan theta, will be equal to 1 minus mu s divided by, okay, let's rewrite it, and we're having 1 plus mu s. So, and theta will be equal to the tan inverse of the arctan of 1 minus mu s divided by 1 plus mu s. So in the question, we're told to find we're asked to find the normal force and the frictional force, which we have gotten to be this. This is our normal force, which is our equation 1, and this is the frictional force, which is equation 2. So, and the second part, we're asked to find the angle, and this is the angle which we've gotten. This is the angle. So, and this is our final answer. Thank you for watching this video. If you have any question, feel free to reach out to us via comment section or send us email at nesalifaacademia@gmail.com.